Hello, great to see you all here and happy to talk here. I will first give you a short introduction into my work in general, and then I will talk about 2 or 3 projects on tea, tree, and clouds. And as an artist, As an artist, I'm working at the experimental edge of art science, new and old technologies, exploring the zone between fact and fiction, fantasy and technology. And in 2003, I have founded a small institute, the Research Raft for Subterranean Refology, it was called. And here you see the first raft on a subterranean lake in Cologne, which appeared during the metro construction. Okay, the main aim of this little institute was to explore subterranean phenomena and spaces such as microscale universe inside stone or earth cores or subterranean icebergs in cooperation with NASA. But since 2007 we are investigating layers of reality, not only very deep down but also very high up, very heavy and very light. I'm probing not only through a hole into the earth but also through a hole into the sky. And I'm comparing the parallels between these two. And I developed tools to search. And with the help of these instruments, the visitor is able to perform a type of field test into possible hidden worlds. And here you see a selection of some tools and methods we have developed so far. And in order to have well-functioning tools, we work together with a qualified team of 2 to 10 experts with different background, depending on the project and its research focus. The teams consist of biologists, experimental computer, hardware, software freaks, and geophysicians, cave explorers, geese breeders. It really depends on the project. And now, after 10 years of successful research and the expansion of working fields and interests, I have renamed the institute into Institute for Art and Subjective Science. We are not producing answers, but questions, and we are probing the unknown, remote realities inside the Earth, outside the Earth, inside smallness, hovering in air, or, for example, inside the ice, here in ice cave Perito Moreno, but also outside the ice cave, drifting ice masses. I really make a run through to some departments. Another department is focusing on the calculation of meteor orbits, and so far we were able to predict 2 meteor falls, and we initiated public meteor watchings here in Yekaterinburg, West Siberia. In last year, here you see 42, the large meteor trap, terrestrial rerouting array pad, and it was installed last year in the desert near Marrakesh, Morocco. And the antenna array investigates the possibilities of calculating and steering a meteor safely down to Earth. Here at night, dawn. Then we are also investigating gravitational anomalies, but I skip this due to the lack of time. Another research branch are private space activities, and I had the chance to take part in some launching tests in the Californian desert. What you see here is Xombi, a vertical takeoff and landing vehicle of Marsden Space System. Here again, the flying sculpture on the ground. These are moon geese, probably some of you know. Another method of private space traveling I started to investigate since 2011 is with the help of moon geese, but it's also a quite big project, and you probably know, so I skip through. In 2007, I was working in zero gravity on board a research plane by the German Aerospace Agency, and surrounded by scientists and their experiments, I realized an artistic experiment to probe cloud cores, aerosols. Again, a big project, and all these different experiments and expeditions, they find their public manifestation in various formats and media. in installations such as here, the tropospheric laboratory, which is based on the experiment in weightlessness. You can see here the original flight lab transformed now in a cloud machine and machine metaphory for the exhibition space, investigating the particles and cloud cores of the exhibition space. But okay, as I said, all these different experiments and expeditions find their manifestation in installations, public happenings, of course, documentary formats, photography, video. So the list is endless. I quick skip through the installation because I go directly to microclouds, what I want to talk a bit more. Because during my preparations for the cloud machinery and for the experiment in weightlessness, I was talking to several cloud scientists, and one was Ulrike Lohmann from Zurich, and she told me that one day she was working in Antarctica and she went out with a hot cup of tea. And the tea didn't steam at all, so she was very surprised that how can that happen? And this is because the air in Antarctica is so clean, there are not enough aerosols, and aerosols are the basis for drop formation and cloud formation. And this conversation was, after this conversation, my interest in microclouds above T started. And then I got this invitation to come to this forest research station, or it's a SMER station for measuring forest ecosystem atmosphere relations in Finland. And I was working there the last 2 summers, and it's a quite large international research station investigating everything nearly around trees, soil, cloud forming, and climate. And when I went there, the first thing I did is I started to drink tea with the scientists, and I developed the first telemetry station. Have a tea with a tree, and here you see 1 tea time. Of course, the microclouds, tea data and tea drinking had to be investigated under several environmental circumstances. And I learned a lot about VOCs, volatile organic compounds, particles, trees, blueberries, mushrooms, and also about tea, for example, how it is used in science. And for example, Lipton-Rooibos tea is the international standard to study soil decomposition. I will show you, beside tea drinking, I encountered also a lot of other interesting methods to measure the invisible. I will show you a few methods from the station.
This box-shaped chamber is used for measuring the carbon dioxide concentration change.
Yeah, and after drinking a lot of tea in 2013, I came back in 2014 with our newly developed instruments, the Teacup tools, and we installed them there in the forest. So to say, the telemetry station got an update. let's have a closer look. So the Teacup tool is about the invisible aspects of climate change and climate measurement campaigns. And they are a multifunctional tool for the investigation of microclouds above the tea, for communication, and of course for tea drinking. And here we did a big measuring campaign at this research station. And we placed the teacups between aerosol measurement tools, between soil chambers, like all these various instruments they have there to measure elements which influence our weather and climate change.
But we have left out one important factor. Earlier, we saw that water vapor needs surfaces to condense on. If there are any surfaces up here, they must be very small because we can't see them.
So these small surfaces, these aerosols or cloud cores, they are microscopic small, like 20 nanometers or even smaller. So if you think about in our air here, in 1 cubic centimeter of air, we can find easily 10,000 aerosols. This has the size of a sugar cube, yes. And they form the basis for drop formation. And let's see how they collect these tiny particles, these air particles at this research station.
This is an inlet for collecting particle samples. So this is an inlet for atmospheric pressure interface time of flight mass spectrometer. This is basically measuring the aerosol chemical composition. Here the particles or the air sample enters the inlet from here and then goes inside the container, and the same is also with this. Here the inlet is located here, and there is the gas chromatograph.
And for example, this is the aerosol hut, and on the roof you see a lot of these filters looking out. And they suck the particles inside, and the analyzing machines are inside the hut. Here again, a view from the side, and of course we had to place our teacup there. Maybe you see it. Oh, we were measuring there with our teacup. Okay, let's have a closer look. What is a teacup? Various instruments are built in and on the teacups, measuring the environment of the cup and the tea and its cloud. And the tea and the cloud is made from anything falling from the sky, made by aerosols, rain, and also litter or leaf that fall into it. And the tea is boiled by the calculation of collected data. Or let's say, let's have a look at the little cloud. The tea produces a little cloud. Here you see it, you can see it a bit with the laser. And the cloud contains the essence of the local air, which is then again investigated. And the cloud again feeds back into the system. So the calculation of collected data is heating the computer. And the energy released by this process we use to boil the tea. So it's an endless loop. And then according to what they measure, they are moving up and down. This really depends on the tea and how hot it is. And it depends on what they are measuring. And it's, so to say, an instant aerosol visualizer, you can call it. So they are dancing an endless choreography made by raindrops, clouds, particles, and tea drinking, and the measurements. So the data can be observed by looking at the cloud, but the data, or the movements of the cups, but the data can also be digested by drinking the tea, and you can also log into the local Teacup Wi-Fi with everybody with a smartphone. And there you can have a look at real-time curves the teacups are writing, or you can listen to data tango. And there's also a message log. The teacups are sending messages. So here's some screenshots again. Okay, I will skip these curves. That's okay, the global teacup network. Air and aerosols, I mean, they doesn't have borders, so it's important to measure at different places. And we are now working on the development of the local teacup network, and we are planning to install the instruments next to aerosol measurement stations in the neighborhood of research laboratories, on rooftops, such as here at the balcony up there, on streets, on roofs all over the world. And we have already several new stations planned. And for example, here you see a typical air measurement station. All the instruments are on the roof. And here's a draft of our mobile teacup container table. It's a table in container aesthetics. We can, like a parasite, place next to the other air measurement stations, and then enabling some tea sessions and tea drinking. Here you see a photo of the station here on the balcony. Some planned setup for Bern in Switzerland, which is more an urban measuring station next to a big traffic street. We have a campaign in Berlin indoors since May. And yeah, there's still a lot to develop. Here just a picture of our telemetry stations, which were set up in 2014 for a workshop. Here during the workshop, the telemetry workshop, also focusing on trees, tree particles, tea and cloud forming. And of course, these kind of projects are only possible to realize with the help of a lot of wonderful people. And let's go now into the larger clouds. Into the larger clouds. So trees emit VOCs, volatile organic compounds. That's, for example, what we can smell inside a forest. They are very difficult to measure because they have a very short life, but VOCs, they contribute to aerosol formation. So therefore, they are also important for cloud formation. So each tea, but also each tree is making its own cloud. I heard that when trees get too much sunlight, they produce and emit more VOCs. So they actually, when they get too much sunlight, they make their own cloud to get into shadow. But it is sometimes very hard to say which cloud is made by which tea or by which tree. Yeah, then again, coming back, so we have millions and billions of super small invisible particles here in the air. And how to measure the invisible? How much reality can I collect with a spoon? How much aerosols fit in one teapot? And for example, how much angels fit onto the tip of a needle? This was, for example, a question very much discussed in the Middle Age, and the answer was an infinite number. Again, here, okay, some methods we saw already to study what leaves are breathing. Here's a tree trunk chamber to see how to become a tree for another tree. Another project, I skipped to the lack of time. Just want to mention that I also started to investigate or to realize my own measurement campaigns, and I started to investigate gas samples. I took gas emissions of amanita mushrooms. Here you see one gas sample taking, and how much fiction does an amanita emit? So it's, for example, it is said that eating an amanita mushroom, reality becomes magnified. A lake, a spoonful of water becomes a lake, and a small hole becomes an abyss. And how many amanitas do I have to eat to see at nanoscale? Here's another amanita with a very visible emission. Again, another gas sample taking. Yeah. I don't know if you can see the emission. Anyway, okay, I just continue. When I came back to Berlin, I started to work at an experimental research arboretum in Zepanik. And I want to end with one theme, maybe. I will introduce you to one last theme I'm working on as well, which is, okay, not only particles and clouds move around, but also trees and plants. So plant migration due to climate change, plants wander up mountains or they go north. And assisted plant migration is a discussed theme, as not all trees can move as fast as climate change takes place. And plant migration can be done manually, such as here. This is at this experimental research station I just mentioned in Berlin, but 15 years ago. And I want to end now with one video 15 years later, which we shot now in spring. Okay, thank you for your attention. I stop.